Good day, and welcome to the first episode of Conversations with the CTO. I'm Jonah McLeod, and joining me is Simplex Micro CTO, Thang Tran. He's best known for designing the first RISC V vector processor currently shipping in the Meta MTIA design. This week at the RISC V Summit Europe in Bologna, CircuitSutra is featuring the Simplex performance model they are developing. So I thought we'd start off with some simple questions about the model. How can you run software on a processor that doesn't exist?
Okay, just like any complex and time-consuming design, like car or airplane, one would need to build a model before the actual design. Building a microprocessor is actually a huge project 30, 40 years ago. It took hundreds of highly skilled in-the-art engineers to design a microprocessor in 3 to 5 years. The most important feature of the microprocessor is performance. Thus, we have performance model to validate the ideas before the actual design. The performance model is written in C++, which takes much less time than writing code in System Verilog.
Well, most engineers are familiar with RTL and FPGA prototypes. How is the performance model different?
The performance model has all the features of a microprocessor and can run benchmark programs to validate performance. We use the performance model to confirm the ideas and to make decisions on specific features of the microprocessor. In addition, our performance model can also be used by customers. You may heard of the term hardware-software co-design. The customer would also have a performance model for their system level design to run application codes before the actual design. They can use our C++ performance model to plug into their system level model for evaluation. We make our performance model very customer friendly, which using a standard compiler and instruction set simulator tools with visualization outputs for easy debugging by the customers.
What workloads are running today?
We ran two benchmarks. Drystone is run to completion, and matrix multiplication is also run to completion. The requirement for the performance model is that the performance should be within 5 to 10% of the actual RTL design. So a major step is correlation between the performance model and the RTL design. If there is any discrepancy, it can be either from the performance model or the RTL is wrong. It is a validation for either the performance model and the RTL. Drystone is compiled with only scalar instructions for correlation with the CPU, and matrix multiplication is mainly used for correlation with the VPU. This is a major task where we would view the pipeline diagram from both the performance model and the RTL. As I said before, performance model is primarily used for validating the idea and the expected performance. Our goal is 400 gigaflops at 2 gigahertz for matrix multiplication. We are on the way to prove that with our performance model.
All right, what's next?
Well, AI is the key for any startup. In terms of benchmark, we plan to run TinyML and Qwen. TinyML is used for edge AI applications, and Qwen is used for agentic AI. We believe that our numbers will show significant improvement in performance with smaller areas and reduced power. The second phase of our performance model is sensitivity analysis and adding L2 cache and perhaps local vector memory for realistic memory behavior.
Okay. So if someone walks into the CircuitSutra booth at RISC V Summit in Europe this week, what should they take away from this project?
We are working closely with CircuitSutra. We're doing a great job. for performance model. The performance model is designed from scratch to run full benchmark in about 3 months. The performance model concept is the same as our mission of simple execution. We are open for customer evaluation and to use our performance model in their hardware software co-design.
Thanks, Thang. If you'd like to follow this project, you can visit the CircuitSutra booth at RISC V Summit Europe this week, or visit simplexmicro.com/blog to see the full benchmark process. We'll be back next week to talk about drystone, GPT matrix multiply, and what RTL correlation actually means.
Thank you.
Thank you.
Bye bye.